Hello everyone, I'm Manisha Kankarej, and today in this lesson we are going to learn about slope of the line. Before I start discussing this concept, let me share something with all of you. Whenever we are discussing this concept, please feel free to share your concerns or any doubt. If you have, don't hold it, because you don't know how much brilliant you are and how much imagination you are filled with. Let me tell you one thing. When I was teaching how to count to my daughter, she was just maybe 4 years old, and she happened to ask me, as we call 21, 31, 41, 51, and so on, why 11 is called 11 and why not 21? So getting that question from a 4-year-old child, it's really like I was amazed. At the same time, it made me think also. So this is just an example. So don't hold yourself. In case you have any doubt, please feel free to share. Coming back to slope of a line. So by the end of this class, you will be able to learn or to find the slope of a line. We are starting from a two-dimensional plane. Then in further classes, you keep on generalizing those concepts. So when I say two-dimensional plane, it means two coordinates are required to find the location of any point. Suppose I want to find the location of this point, then I need x coordinate as well as y coordinate. Why only two coordinates? Because this plane has two dimensions, length and width. Suppose I want to find the location of any point in this space like this. So I need length, width and height. So that is how we generalize from 2 dimension to 3 dimension and so on. So we are starting to learn this concept of slope of a line with respect to 2 dimension first. To find the slope of a line is nothing but the angle. This is the angle made by any line on with x-axis. There are two coordinate axes, because we are talking about 2 dimensions. So we have horizontal axis, which is x-axis, and a vertical axis, which is y-axis. And this horizontal axis is again divided into positive coordinates and negative coordinates. Similarly, the vertical axis is again divided into the positive coordinates and the negative coordinates. So to find the slope of a line, we need two coordinates first. So if we want to find the slope of this line, so what we are going to do is we need to identify 2 points on this line. Suppose I identified first point, and this point is 1, 1, and I identified second point, that is 3, 3. I'm naming this 1, 1 coordinate as x1, y1, and I'm naming this second coordinate, which is 3, 3, as x2, y2. My aim is to find the slope of this line. Means I'm trying to find out what is the angle made by this line with respect to x-axis. Now, where do you use this concept? We are going to learn it after I'm done with this concept. Slope of any line is given by rise. Rise means the change in the y coordinate divided by run, which is the change in the x coordinate. Means how much is the change in y divided by how much is the change in x. So when I want to find this difference, then this difference is the highest point of y, that is y2, minus lowest point of y, which is y1. So y2 minus y1 is the difference of the y coordinate, which is the rise. Similarly, difference of the second x coordinate with respect to first x coordinate. So x2 minus x1. So this ratio of the differences of y coordinate to the differences of x coordinate, this divided by this, gives us the slope of that line. And this slope is nothing but the angle made with x-axis. When I say with x-axis, you might think that this line is not x-axis. But because this line is parallel to x-axis, parallel lines have same slope, that's why we can consider the slope with respect to the line parallel to x-axis also. Now, where do we use this slope in real life? Where do we see this in real life scenario? To find it, you can say that when we find the speed. Suppose I have the distance given on y-axis and the time given on, or time plotted on x-axis, distance on y, time on x. At any 2 points, I can find the coordinates corresponding to them, and I can find the differences of the y coordinate, which is the distance coordinate, divided by these differences of the time coordinate, which is on x-axis, which will give me rise over run, and that will be the slope of that line, which gives me the speed. So speed is the example of slope of a line when I want to connect this information to real life scenario. Now you might think, where are we going to use this concept in future in study of calculus? When you are studying calculus, calculus is nothing but the study of frequent changes. So if you look at these 2 points, you are finding slope at 2 different points. When these points are coming very close to each other, you are getting into the calculus part, and that's the differentiation or derivative of a function. That becomes this rate of change becomes the instantaneous rate of change in that case. So this is just the basic, or I would say that this is laying foundation for learning new things. So you might have seen these things, or you might have been using it in real life scenario, but I'm just showing you how are these things connected to math in our real life scenario. Is this explanation fine for everyone, or anybody has any question related to it? If not, then let's look at some examples based on how to find slope of a line if we have been given some graphs. So what we are going to do, we are going to identify the points, 2 points on that line, and then we are going to find out the slope of that line using this rule. So we have learned the theory now, and we are going to look at how to apply this theory to the questions. So all the students who are sitting in pairs, those who are not sitting in pairs, just try to make the pairs so that you can work together. Meanwhile, I'll go through everybody's work just to see how are you solving these questions. Let's look at first few questions, starting with question number 1 of your exercise. And in case if anybody is having any difficulty, I'll help you with that also. So remember, this is how you find the slope of the line, y2 minus y1 over x2 minus x1. This is the ratio of the differences of y coordinates divided by the differences of x coordinates. Thank you.